even get started on our learning target, I had an epiphany last night, and I thought, you know what? Now that we are using 4 operations in math, which means we are not only multiplying and dividing, we are responsible for adding and subtracting. I noticed that some of the problems we're going to be solving have some really, I guess I would say 3-digit addition and 3-digit subtraction that I don't think we've done in a long time. So I'm going to start out most math days with a review of basic 3-digit addition and subtraction, because you were supposed to have mastered that in 2nd grade, but we all know we had to go remote, right? We went remote and you weren't in class and things might have been tough, and I don't know how many of you have been practicing that, but Cooper actually gave me the idea because we were working on Think Central and he said, well, do I add those numbers? And I said, well, what do you think? And he said, I think I do. And he said, I was hoping I could because I'm excited about it. And they were 3-digit numbers he had to add. And he was excited about it, which made me excited. But not everybody might feel that way. So get out your math spiral. We're going to start with a couple addition 3-digit problems. So I'm going to start with a basic problem. Go ahead and write this down, and I want to make sure you have it lined up. When I say it needs to be lined up, so you've got to have your math on, bud. That means the ones place should be in the ones column. The tens digit should be in the tens. So this is your ones, your tens, and your hundreds. So if it is not lined up, that could be a problem, couldn't it, Elena? Why would it be a problem if it's not lined up? I could add the wrong numbers, and then I'm going to get the wrong answer. All right, so Noah, oh, you're not in my math, sorry. I'm as bad as you. Angelique is gone. How about Abby? I pulled your name out of the can. Abby, are you with us?
I do not have an Abby.
Abby, you're with us. What should I do first when I see a problem like this?
Add the ones.
She says I should add the ones. I'm going to agree with her. It's not the only way to do the problem, but for today, that's the way we're going to practice, okay? You're going to learn a lot of different strategies, but right now we're going to go with the traditional US method of addition. We're going to start in the ones place. So let's do it together. What's 5 plus 3?
8.
Go, where do I go, Abby?
10.
To the tens. What's 6 plus 3?
9.
And then go to the hundreds. What's 2 plus 1?
3.
3. Is that pretty easy? Pretty simple?
Yeah.
Not too shabby, right? Do you guys remember that from last year?
Yeah.
Yeah, I think your teachers would say, Mrs. Alvin, we spent a ton of time on that last year. So I don't think this is going to be too difficult. But here's what's going to happen in your math problems. You might get a problem that said, Joey had 168 coins. And then he got 234 from his cousin. How many coins does he have now? I want you to solve this the same way, but there's going to be something you have to do. When you find that the answer or the sum in your ones place is greater than 9, it poses a little bit of a problem. So go ahead and write that. Make sure you have them aligned. That means they're in the ones that your digits are lined up, and that you can explain, what do I do? When 8 plus 4, I'm going to start in my ones place, right? Start in the ones place. If I say 8 in my head, 9, 10, 11, 12. I get 12. Am I going to write 12 there? No. Raise your hand if you can explain what I need to do. All right, Max, what should I do?
You should add 8 plus 4.
Okay.
And then you take the 1 and you put the 2 there.
Okay, so we decided 8 plus 4 is 12, and you're telling me I take the ones, because this is the ones place, and I put it here? Yes, what do I do with the 10?
You put a smaller one by the 6, then you add 1 plus 6 plus 3.
Okay, so now I have a 1 in the tens place because I made a new group, right? So now I have to add 6 plus 1, which is 7, 8, 9, 10. Do I write 10 here? No. And because I made a new 100. Now, do I add that in with these hundreds?
Yes, it equals 402.
Okay, 1 plus 1 is 2, plus 2 more makes 4. So that would be 400. And I'm going to challenge you not to say and until you get to decimals. And should be reserved, Ellie, for decimals. So let's see if we can read this number without saying and. Ready? 402. Let's read this one without and. 398. We don't need and. You will need and when you get to the decimals. Like when I say $1.50. Right? That decimal will say and then. All right, let's try. Now that you kind of have the idea, I'm going to give you another addition. Let's do 572 plus 239. See if you can do that with carrying that 10 or carrying that 100 to the next place. Make sure you have them lined up. This might not need to. You gotta make sure you know it. Okay. All right, Jensen, can you tell me how to solve this problem?
Yeah. So 2 plus 9 is 11. So you carry the 1 to the 7 and you place 1 there.
Now what?
And 8 plus 3 is 11 and carry the 1 to the 5 and place 1 there. And 6 plus 2 is 8.
So he got 6 by adding that 1 and the 5, and then adding the 2, and he got 8. Give him a thumbs up if you agree. All right, we're going to try one more, and I'm not going to do subtraction today because I want us just to get reacquainted with the addition. Let's try this one. Let's do 625 plus 475. Try it, line it up. I see a lot of people panicked because we went into a higher place value.
100 minutes.
Okay, Robert, do you want to unmute and walk me through this?
Yes.
Okay,
I know the answer. The answer is
I don't want to know the answer. I want you to tell me how to do it, Robert. What do I do first?
we know that 6 plus 4 equals 10. So in the 100, it would equal 1,000. 1,000, pretty much. And then I know that 2 plus 9 equals, 2 plus 7 equals 9. So then, 10. So then 1,090, and then 5 plus 5 equals 10. So it equals 1,100. Yeah, it equals 1,100.
Okay, so you did a strategy or method called you did it where you added the hundreds first, then the tens, and then the ones. And there's a name for that method, but I can't remember it. And I think that is fabulous because you really have good number sense that you can pull those numbers apart. So he added 600 plus 400, and he got 1,000. Then he added the 20 plus the 70 and got 90. And then he added 5 plus 5 and he got 10. And then he added them all together and he knew that would equal 1,100 or 1,100. That's really a cool method. But today I'm going to walk you guys through the other method where we start in the ones place. You should have said 5 plus 5 is? 10. Put the 0, carry the 1. 1 plus 2 is? 3. Plus 7 equals? 10. Put the 0, carry the 1. 6 plus 1 is 7, plus 4, 8, 9, 10, 11. And then a lot of you didn't know where to put the comma. You count over 3 digits. 1, 2, 3, and that's where your comma goes. And when you see that comma, you know it means 1,000. 1,100. Let's say it without saying and. Ready? 1,100. Oh, I heard an and. Try again. No and. 1,100. Okay, nice job. So we will get better at that. And Robert, we are going to talk more about that method that you use. That's really good. I also want you to practice the other method just to have more tools in your toolbox. Because that sometimes when the numbers get bigger, it's good to have more than one strategy. All right, so our learning target today is going to sound similar to what we did yesterday. We are still going to be working on strategies for solving two-step word problems. And that is because we said yesterday, most word problems don't involve only one step. You'll be able to practice those count bys in your problem solving. We'll use the order of operations again to help us solve these problems, and then we'll actually do it. So who can remind me of what the order of operations is before I give it away? Does anyone remember the acronym for it?
Please excuse my dear Aunt Sally.
Wow, I'm so impressed. Please excuse my dear Aunt Sally. So, and I have to tell you, I told my kids what I was teaching today. They could not believe how smart you guys are to be learning this in 3rd grade. So the order of operations is just to remind us that when you see a problem that has parentheses, an equation, you need to do the whatever inside that parentheses first. Remember, we highlighted it yesterday under the doc camera. I used my pink and showed you that. So I think I still have it. That is what you're going to use first. Exponents we don't do in 3rd grade, but we still can use that for our memory, the E for excuse. Then you're going to do multiplication and division, and then addition and subtraction. That is the order of operations. We said, please excuse my dear Aunt Sally, PEMDAS, and we actually taped it onto our math spirals. So guys, here's our steps for problem solving. We don't want to forget that. Even though, Elena, even though we're doing 2 steps, guess what? I'm going to do a quick, let's see. You know what? I need to give a pause ticket to Serne. Serne, thanks for whole body listening. Drawing on the desk again. So, Serne, thank you for being respectful and listening. Hey guys, when you have whole body listening, your hands and feet are down and still. You're not drawing on desks or drawing on anything, right? Thank you, Serne, for being such a good listener. Even though we're doing 2 steps, we're still going to use these same strategies, but how many times?
2.
Twice. We got to do it twice because we're doing how many steps? 2. And before we get started on this, I just want to review one more thing here. So there's our PEMDAS. Yesterday we talked about how we come up with questions. There was our PEMDAS from yesterday. Remember when I said I highlighted in pink? That's what I meant. So we knew to do whatever was in parentheses first. That was our PEMDAS. And then we also spent time on writing a question when we had to figure out, what do I want to know? Like Anna read 383 pages this month. Chris read 416 pages. We decided the question should be, how many pages did they read altogether? When you're doing 2-step word problems, you have to figure out the first step question. So turn to page 133. We're going to look at this first. Page 133 in your math workbook. And I'm going to help you think about what would the question be. And the reason we want to do that is if you don't know what you're trying to figure out, Lucas, then you don't know what the first step is. So page 133. Thank you for getting there so quickly, August. I'm going to give you a pause ticket too. Thank you for being a good listener. That might be a little brighter. Can't quite tell. All right, a roller coaster has 7. Oh no, don't get your ticket. Oh, there it is. A roller coaster has 7 cars. Each car has 4 seats. If there were 3 empty seats, how many people were on the roller coaster? So we have a question, but this is a 2-step word problem. I want to write the first step question first. Where do you think the first step ends? A roller coaster has Sunny Pearl. Here's the first step. Good. After each car has 4 seats, go ahead and draw a line there. For this one, it's pretty simple. It's right in the beginning. It even has a period. The first step is not always at the beginning of your problem, however. Sometimes it's embedded or it's at the end. So be careful with that. For this one, though, if I know a roller coaster, Haley Booker, has 7 cars and each car has 4 seats, I want to know, what do I want to know first before I can find out how many people were on the roller coaster. What do I need to know first? If a roller coaster has 7 cars and each car has 4 seats, I need to know how many cars what?
Or no?
Sure. In all. Go ahead and write it. How many cars in all? I need to know that before I can see how many people were on the roller coaster. I can't do the second step until I do the first step. What would that be? What would be put it in parentheses? What's my first step to find out how many cars in all? There's 7 cars, right? 1, 2, 3, 4, 5, 6, 7. There's 4 seats in each one. 4. We'll get a picture of 4, but I just want, what operation do you think this is? Here, if you're not sure, think back. Repeated addition falls under what operation? Multiplication. 7. What would the equation be, Sawyer? A roller coaster has 7 cars. Each car has 4 seats. So put 7 times 4 in parentheses in the first question. Before we answer the second question, how many people were on the roller coaster, we have to answer how many cars in all. So what's 7 times 4? John? 28. How about that? That makes more sense. So I'm going to write that right below, or you could write it above. Go ahead and make sure you have that written. But now I still am not done. I have a second step. If there were 3 empty seats, 3 of these 28 seats are empty. How many people were on the roller coaster? The rest of the let's go 7, 26, 25. So we should get 25 people. If we want to know how many people on the roller coaster, we know there's 20 seats and 3 empty. Right? Let's look at number 19. Each week, I think we might have some hidden information. Each week, Marta earns $10 saving. She always spends, oh, no, it's not hidden. She always spends $3 and saves the rest. How much does she save in 8 weeks? This one is not at the beginning. Remember when I said they can be embedded? Before I can find out how much she saves in 8 weeks, if she has $8, 8 weeks, she gets $10 each week. First, I need to know how much. Let's think. If I should know, what do you know? What do you know?
Need to know how much dollars she gets each of those 8 weeks.
You're right. We need to know how much does she save each week. Right? Because she gets $10 each week, but she spends $3 and saves the rest. So how much does she save? That's what I have to know before I can answer how much does she save in 8 weeks. What are you thinking, Evie? What do I put in parentheses? What's my first step to this problem? Well, let's see. We start. She spends. Let's back to this. Operation that. Subtraction. So we're spend $3. The rest. Another key word there. What is the rest? What is the rest? 10 minus 3. You have 10 fingers. Take. What is the rest? 7. So she saved $7 in 1 week. But what we want to know, how much does she save in 8 weeks?
7 times 8.
Why?
Because if you have 8 weeks and she saves 7, then you need to know how many she saves in 8 weeks.
Excellent. Because it's repeated addition. We don't know the total. And it's the same number multiple times. 7, 7, 7, 7, 7, 7, 8 times. 7 times 8. What do you think? Why 56? 7 and, no, that's, which one is that? 7, 6, that's the one. Okay. All right, let's move to number 20. I put 6 packs of stickers. Each pack had 8 stickers. Then I gave him 10 more stickers. How many stickers does Abu have now? Show me where you would draw the line for that first step. Serne, where do you think it is? Where am I going to ask that first step question? Don't say how many, right? Abu bought 6 packs of stickers. Each pack had 8 stickers. Then Abu's friend gave him 10 more stickers. How many? How many stickers Abu has? I know how many. Or that works too, Elena.
6 times 8.
All right, so what's our first equation? Lucas, what do you think? If I have 6 stickers, there's 1, 2, 3, 4, 5. Go back to this. Repeated additions. Times we do the total. What operation is that? Multiplication, yeah. 6 times 8. That's the one we want. Come back. There were 48. 6 times 8 is 48. Awesome. All right, are we finished? Gabe, we're on 133. We are not finished. Charlie, what do I do next? I know there's 48 stickers in all, but then Abu gave him 10 more. So we don't know the total. And it's, what are the key words there? He gave him, can you visualize that? Getting more? You guys know when you get money, you add it up, right? Same with your stickers. This is like real life experience. I have this many more. Now I have this many. It's growing. All right, let's look at the She put 4 apple slices. Oh, this one's tricky. And 2 melon slices on each plate. After there's 4 slices and 2 melon slices on each plate. She prepared 5 plates. How many slices of fruit did she use? Where does the line go?
I think she put 4 slices and 2 melon slices.
Yeah, good picture. Could be 4 apple slices. Okay, here's me. And I have 2 of my melon slices are going to look a little weird. Those are my 2 melon slices. I want them to look different. Is that repeated addition? Is it the same number again and again? Yes. No. We want to know what? We want to find out how many slices of fruit we use. We have to know first on each plate. How many slices on each plate? That's what I got to figure out first. Once I know that, then I can find out how many slices are on 5 plates. So, how am I going to do that first step? Get your parentheses ready. What's going to go in those parentheses for your first step? Zoe's not 4 slices. Look at my picture. Multiplication. Right? We said it wasn't because we don't see the same number. Why is it addition? Okay. Okay, guys. That's okay. Let me focus. Yeah, the numbers together. I do not know the total. So we have 4 2 now. We add those. Lyric, did you want to share your thinking? Okay, microphone answer. What's 4 plus 2? We have 6 on each plate. But now it says she prepared 5 plates. How many slices of fruit did Zoe use in all? So now I've got 1, 2, 3, 4, 5 with 6 on each plate. Do we see repeated addition?
Yes. So we have to multiply.
It's repeated. We have 6 multiple times, 5 times. Do we know the total? No. So what are we going to do, Sawyer? What do we have to multiply? 6 times what? How many plates are there? 6. In parentheses, we had add 4 plus 2 to 6. And then I figure out like number 6 below it so I don't forget and do 5 times 30 and okay, I'm number 5. We don't get the question. What thing about the question? You're probably glad. You're probably thinking, oh. But on, yes, Finn. Yep, that's what we did. Excellent. I'm proud of you. All right, page 135. Now, this is what it's going to look like on page 135. It's not going to tell you to write the question. You have to be thinking, what do I need to know first? How many what? That's what your job is. And you're going to be amazed at how quickly you can figure it out. I'm going to let you guys, we're going to work on one together on page 134. Am I on the wrong one? That happened. Let's see. And then, did I get them backwards?
It's the same question, but
It's 134? Okay. I believe it. Nope, it's 135. Actually, it's right that time. That's the one you had different. Because that's the one where you write the question. Okay, so it is 135. And you don't have to write questions. So let's see what it looks like without writing a question. 9 hens laid 6 eggs each. 5 of the eggs broke. How many eggs are left? I'm going to do an I do, we do, and then you guys are going to do. So I'm just going to model my thinking. I'm going to visualize this. I'm going to retell it. 9 hens laid 6 eggs each. 5 of the eggs broke. How many eggs are left? I think 9 hens laid 6 eggs each. I think I need to think of a question here. How many eggs are there in all? I'm thinking that in my head. I'm not going to write it. So if 9 hens laid 6 eggs, in parentheses, I know that's 9 groups of 6. I need to figure that out first. Then I know 5 of the eggs broke. I see a key word. It says broke. I'm going to take those 5 eggs away because they broke. Then I'm going to find out how many eggs are left. And that keyword left tells me I'm going to subtract as well. So now I'm going to use my nines trick. And I'm going to find out that 9 times 6 equals 54. I like to write that up there so I don't forget. Now I have to subtract 5 from 54. So I'm going to just say, well, if I took 4 away from 54, that would give me 50, and 1 more would give me 49. Then I'm going to look for my unit after how many, and I know it's going to be 49 eggs. Okay, you guys are going to help me with the next one, and then you're going to work on some of these. The next one says, there are 8 houses on Jeremiah's street. Each house has 1 willow tree, 6 apple trees, and 2 olive trees. How many trees are on Jeremiah's street in all? What do I have to know first before I can find out how many are on Jeremiah's street in all? Any idea? Haley?
you have I just had it and now I forgot.
That's okay, surname. Page 135. So we're on number 2. So let's read it again. This one's tricky. It's not straightforward. There are 8 houses on Jeremiah's street. Okay, so let's draw a picture. Here's his street. I've got 1, 2, 3, 4, 5, 6, 7, 8. But each house has trees on it, right? Like near it. Each house has 1 willow tree. These are all trees. 6 apple trees and 2 olive trees. I want to know how many trees are on Jeremiah's street in all. But before I can do that, I need to know how many what? What's our unit? What are we talking about? How many trees each Add 1 plus 6 plus 2. We got to figure that out first. That'll tell me how many trees each house has. Can anyone tell me how much 1 plus 6 plus 2 is? Ben. I want to know how many trees. 9. Marin. 9. Because 1 plus 6 is 7 plus 2 is 9. So I've got 9 at this house, 9 trees at this house, 9 trees at this house, 9, 9, 9, 9, and 9. That's a lot of trees. So I'm not done. What's my second step? I have 8 houses with 9 trees at each. How many trees are in Jeremiah's street at all? What do I do next, Charlie? So I have to multiply that by 8 because I have 1, 2, 3, 4, 5, 6, 7, 8 houses. What is 9 times 8? 72. 72 trees. That's a lot of trees. All right. I know this is a big step, adding 4 operations and also 2-step problems, but you guys have just proven to me that you can do it. So I want you to work in breakout rooms, and we're going to see how many you can get done. We'll probably just have time to do page 135 today. We'll save page 136. I have time next week to do more problem solving. So look at numbers 3, 4, 5, and 6 if you get to them. And Mrs. Harrison, if you don't mind, they can work in partners. You guys can go ahead and get started. Yeah, it's not going to let me do it. Sorry.
I know. Miss Auburn.
Hi, guys. I'm just popping in to say hi. You guys know what to do?
Yeah.
Okay, go for it. Pretend I'm not here.
Tim has 9 marbles. Ryan has 3 fewer, so that's 6. So that would be, pretty sure that would be 9 minus 3, I think. And then times 5? No. Dwayne.
It's 15 minus 9.
50 minus 9?
Yes.
Wait.
Equals 6.
So what would the equation be?
The next one,
What would the equation be for the third one?
two times 4 minus 4.
Okay. 2 times
4.
2 times 4 equals 8. Minus 4 equals 4. Is that it?
Yeah. It's just basically 4 and 1, 2. Easy as pie.
Welcome back, everybody. Thank you, guys. I want to say how proud I am for how well you guys persevered. It was not simple, but you guys really did a great job. I'm going to quickly go over the answers. I can't teach it, but I want you to check it, okay? So let me share my screen. And we're going to just go over the last four. Hopefully I get to the fourth one. Tim has 9 marbles. Ryan has 3 fewer. That should have told you to subtract. Then Tim, which would give you 6. Leslie has 5 more marbles than Ryan. So if Ryan has 6, 5 more than that would have given you 11. 11 marbles. And Mr. Helms has 2 stables with 4 horses in each stable. 2 ways you could have done this. I saw it done 2 different ways when I came around. You could have said 4 plus 4, or what was the other one? 2 times 4. Either way, you should have gotten 8 horses. Miss Martinez has 4 more horses than Mr. Helms, which means you're adding 4 more, and you would have gotten 12 horses that Miss Martinez has. Hey, Angela had $4. She bought 2 pumpkins for $1 each. So this one's hard because of the order. I saw Henrik do this real quick. He already knew she spent $2 because he was thinking, well, she bought 2 pumpkins and they were $1 each. 2 times 1 is 2, right? But she started with $4. She had to subtract that $2 and you would have gotten how much money she has now? She has $2. Ahmad had $40. He bought an action figure for $5 and a backpack for $14. Well, I know before I can find out how much money he has left, I have to add the $5 plus the 14 to know how much he spent. And then he started with the 40, so I would subtract whatever he spent from the money he started with. That's a real life problem. That could have your name there, right? That's like you guys going to Target or to the mall and saying, I have this much money, I bought these things, or going to Leo's Toy Store. 5 plus 14 would be 19, then you need to subtract. So this is why we're going to be reviewing how you do that. Hopefully you remembered from second grade. 0 minus 9, I can't do that. I got to borrow from the 10. Take that as 10 minus 9 is 1. 3 minus 1 is 2. You should have gotten $21 left. All right, I do have an exit ticket. Today, your exit ticket kind of goes with yesterday's lesson and a little bit of today's. I want you to explain on your exit ticket the order of operations. Guess what you can use? You can use your math spiral. And if you are at home, it is on your Google Classroom. It is a Google Doc. Please should be on my desk. And you will be turning it in when you are done. Explain the order of operations for solving 2-step word problems. I'm going to give you a hint. PEMDAS. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. This is exit ticket 1 because we're starting a new sheet. Any questions from home or remote? Okay, I'm going to just show you where that is for my remotes. When you go to math, on today's lesson, There's your exit ticket. So Lyric, Lila, I need you to do this ticket for me today. You type it right on the Google Doc. And then you press turn in. Here's your hint. PEMDAS. Use your spiral to help you. Oh, this is nice. As soon as you have your name on yours, go ahead and answer. You can use this. You can use this to help you. Please excuse my dear Aunt Sally.
What? No.
Your name's Fred. That's the last thing I do. What should you do first? What's your order of operations? When Mrs. Alvin, where are your little ones? Now we're gonna get one. No, we got I got plenty. Thank you, thank you. Oh, boy. You should know. I just started going to your things. I know, yes. Which one will head to that? We're married now. What is mine and yours? This one? I'm pretty sure. Tell me what they tell me which one. Mine is yours and yours. Yeah. Did you have two on side? You I got it right. Wow. 4. Okay, guys, I'm going to let you do your exit ticket. And then I will see you guys on Monday. Have a great weekend, okay? Great work today.